time. Shh. Swatch is watching. Shh. Swiss time. Good evening. Welcome to the first spring lecture series at the School of Architecture. Just to announce ahead of time, it's going to be a bit of a break in the series. The next lecture will be 4 weeks from today. It'll be our own Bob Brugman on March 9th. And a week after that, on March 16th, will be Michael Hayes from the GSD and the Whitney. And then after that, we'll speed up after the break, and there will be 5 lectures in April. There's a Wednesday episode at 1 this week and next week. This week it's Code 46, the film, and next week is the Barcelona-Berlin traveling studio presentations. Also, to remind you, and which accounts for the little gap in our action, the NAAB accrediting team will be here in 3 weeks. Among other things, seeing them around the building, there will be an exit meeting here with the entire school on Wednesday the 25th at 10:30 a.m. and you're all encouraged to come to that, and there'll be signs up. Tonight it gives me great pleasure to welcome Marc Angélil to UIC in Chicago. Marc was born in Egypt and educated in Zurich at the Swiss Federal Institute of Technology, the very well-known and internationally significant ETH, or AKA ETH, where he received his professional master's degree, as well as completing his doctoral dissertation on the subject of technique and form. He's taught at the Harvard GSD, at the University of Southern California in Los Angeles, and has been a professor at the ETH/ETH since 1997, where he's been responsible for designing and directing the first-year foundation course, as well as directing the Institute of Urban Design, which is a research center that addresses recent developments on the urban periphery. Marc will also assume the position of Dean at the School of Architecture at the ETH when he returns there tomorrow, so tonight is one of his last moments of unscheduled freedom. So my condolences to Marc. In addition to all of his educational accomplishments, Marc is a founding partner and probably the most frequent flyer of AGPS, Angélil Graham Fenninger Scholl, with offices in Zurich and Los Angeles. Among AGPS's award-winning projects include the Midfield Terminal at the Zurich International Airport, the town center and rail station of Esslingen, as well as remodeling and factory for housing and commercial uses, which has a fantastic restaurant, if that's what I'm thinking of. Current projects include the headquarters extension of the World Conservation Union in Geneva, the Children's Museum of Los Angeles, an aerial tram in Portland, Oregon, and an urban renovation project in Addis Ababa, Ethiopia, just to give you a sense of the geographical scale and institutional scope of the office's work. Finally, Marc is a member of the board of the Wholesome Foundation for Sustainable Construction and a frequent writer on architecture with a collection of essays that have recently come out on the political economy of urban territories. I suppose what is most annoying about Marc is that there's no one I know who does more things more well than Marc. As an architect and designer of all scales of projects, some of which you'll see tonight, as an educator, a writer and researcher, an impresario and nurturer of young design and teaching talent, and as an administrator. Marc possesses an envy-producing organizational intelligence, which you can see not only in the fact that he runs a 60-person office that has offices half a world apart in Zurich and Los Angeles, but also for the foundation course that he's been directing for 10 years at the ETH that has to introduce the discipline of architecture in the first-year curriculum to 300 17-year-olds every year. And I think they meet only once a week. So I don't know even how that's possible. The work that's come out of that first-year education foundation, as well as its graduates, is without precedent, I think, in recent education, and has been documented in 2 collections, Inchoate the first and Deviations the second, both of which have been strong influences on what we've been trying to do here as well, both in both first years, really, both foundations. In his design work, as well as teaching, Marc is the embodiment of rigor and experimentation, peculiar alchemy of his Swiss and American context, and a role model for that all too rare combination. Personally, I've learned many lessons from Marc, but two of them are: one, if you're ingenious, it's always possible to get your way in a design project, even when confronted with ridiculous demands and outside experts. And two, if that fails, on occasion, it's very liberating and pleasurable to fire your clients. Please join me in welcoming the always exacting and generous Marc Angélil.
Well, thank you very much for this extremely kind introduction. It's a great pleasure to be here. What I would like to do today is take you to a series of projects rather quickly and focus on specific aspects of the work. And as I just heard that the accreditation board is going to be here, I'm dedicating this lecture to them because I'm going to talk about technology and about the techniques and the doubts we have vis-a-vis this mysterious let's say assemblage of phenomena that we are facing in our discipline. And it is in this spirit that I'm calling the conference tonight Negotiating Circumstances. I think this is what we do as architects. We have become amazingly creative creatures trying to negotiate these very difficult and sometimes absurd circumstances that we encounter in our professional lives and trying to do magic out of it. So I'm going to focus also on questions of processes, of how processes are being designed in the architecture office, not just the product, but also the way to get to this potential product, and show you also the failures that we encountered in trying to address these types of processes. Now, very important, Paul mentioned, it's not possible for me to do everything alone, so I rely on understanding of architecture as a collaborative enterprise. Those are the people in the offices, and everybody is extremely important that has certain talents that we try to nurture and try to promote and deploy in the work. Everybody works as an individual, but has to have also the ability to collaborate as a pack of wolves, as in a guerrilla type of operation, in order to react correctly at a certain moment. Designing sometimes on the run while on the phone. We have two offices that we consciously created in a very similar way, so there is a similar ambiance. On the left you see the LA operation that is currently struggling to survive due to the economic crisis that we encountered. And the Zurich office still booming, not realizing that there is a global crisis. Two fundamentally different cultural contexts in which we operate. Ultimately, at the end, architecture is architecture. Both offices fight for, let's say, strengthening architecture as a discipline within the political frameworks that we have to operate. But moving from one office to the other, one encounters a cultural jet lag between two fundamentally different ways of thinking. This is the place of production. This is where the work is done. But the work is taken beyond the initial design phases into design development, working drawing, project management, construction management, and work in situ on the construction site. And in many of the projects, we've decided to be our own construction, how do you call this in the States when you are the construction manager? The contractor. We are the contractor of the biggest projects that I'm going to show you, while some of the small ones were done then with general contractors that were not part of the office. So very consciously we push the process of architecture beyond just design. And I don't mean just in a negative way, but let's say we take design till construction. So the work on site is extremely important. On the left, is a horse ranch that was just completed, where there was a lot of work to be done, infrastructural work to be done on the site, with there were various types of machineries there. And this is the airport where we had to build an airport while it was under operation, which turns into a logistical nightmare, but somehow we managed. So we are very much interested in this, and the people, the pack of wolves is trained to operate in this context, and I have to trust them. So the work that I show is also credited to them, not just to the partners in the office. This is very important to us. We promote a discourse on method, and discours sur la méthode, within the office in a series of seminars. So we take a model that we are accustomed to in the university context and plug it in the context of practice and ask people to read. Sometimes it's very surprising. We ask them to read text by Rosalind Krauss, or in this case here, certain fragments of excerpts from Alice in Wonderland or Looking Glass. Then recently we had a debate in the office on Alejandro de la Sota's work, trying to thematize questions of tectonics and whether the tectonic aspects of architecture need to be formally expressed or not. And then another piece that was quite important to us was an analysis of a movie. And this is done every week, where there are certain people, the office comes together, there's beer, and we discuss issues and try to promote discourse. And we are very critical also of ourselves. So sometimes projects are shown and they're being ripped apart like in a review in any school of architecture. You know this well. So I stand like a little boy in front of the project and everybody shoots. So, for example, Alice through the Looking Glass by Lewis Carroll, just a few lines. Let's pretend we are architects. This is extremely difficult for somebody in a Swiss context to say, let's pretend. So we had to promote this notion, let's pretend to be something else. Or let's pretend that there is a room in the mirror where things go the other way. Let's try to take another vantage point and see that. I can't believe that. I hear that often in the office. I can't believe that. It is impossible to do. Can't you, the Queen said in the meeting room, try again, draw a long breath and shut your eyes. Alice laughed. This is something that needs to be promoted also in the Swiss context. Laughter, the ability to laugh. There is no use trying, she said, one can't believe impossible things. I dare say you haven't had much practice, said the Queen. When I was your age, I always did it for half an hour a day. Sometimes I believed as many as 6 impossible things before breakfast. So nurturing the idea that one can believe an impossible thing and move from fact to fiction, as was discussed today in one of the reviews, the possibility of thinking the impossible is extremely important in our field. I think we are probably the only ones that can do that. And synthesizers and back. Those are some images that we showed in the seminar a few weeks ago on this school that Alejandro de la Sota built in Madrid, where we studied section models and then the transfer of these tools into the built artifact. So we were interested in this possibility of transferring from drawing and model into artifacts and discussed here the possibility of inhabiting the structure. So you need a load-bearing structure, but can it be inhabited with seminar rooms and lecture rooms, for example? And then the Mépris was very important by Jean-Luc Godard, who is a Swiss filmmaker, French-speaking Swiss filmmaker, 1963, Content. I showed you the opening scene. Godard works in the documentary genre. He's very conscious that he's using the genre of documentary, and I think that our buildings might have similar aspects to them, quite documentary in the way. Furthermore, he displays the machinery of filmmaking in the opening scene of Le Mépris. So he declares that what you're seeing is a movie. And in analogy to that, we are very much interested in the means and techniques that are being deployed in the machinery of making architecture and foreground those aspects. that doesn't mean that we express always structure. There might be certainly a process component that might be foreground. In this movie, he thematizes also the financial structure of the movie. In this case, there is an American and an Italian film producers, and they have different objectives. Then you see the camera, because of the camera stylo, where he deploys clearly the camera working in the CinemaScope format, showing you what you will see on stage. And then he uses the norms of filmmaking, but deviates from them. The credits are not written, so he moves from the visual realm to the auditive realm. You hear Jean-Luc Godard stating, it is a movie with Brigitte Bardot and Michel Piccoli, and it's a movie by Jean-Luc Godard. So he consciously tweaks a certain convention in order to achieve the specific effect. At the end of the scene, he shows the camera, okay, and directs the camera then to the audience, moving away from the authorship of the director and giving credit to the audience that will read and rewrite his piece of cinematography. And he was extremely interested in the proportion of this new technique that he had found. It was the first movie in color using CinemaScope, and those are the proportions that you see here. So those are some ideas that are behind the work. I would like to take you into how we try to negotiate these circumstances in 13 different projects and only address a few little aspects. So this was our first project in the US. Sarah and I moved to the new continent. We're extremely excited to be in California, just below the Hollywood sign. We wanted to build a house. Found an extremely cheap piece of land that nobody wanted to touch because it was too steep. So we said, okay, for Swiss, this is not a problem. Master any steepness that you want. And we went to Over Arab and negotiated with them a very cheap fee and convinced them to do a little house. Their invention is this Virentile truss that is folded into the hill, holding the hill in place. So it's great beams, but folded, holding the upper and the lower retaining wall into place, on top of which we placed the house in steel and wood construction. You see the steel members here, the wood is infill. The wood is holding the steel in place. So here we were tweaking certain conventions. So this house wouldn't hold up without the wood. The house was floating with 0 tons in the calculation. So all the work went to this foundation that needed to be treated like gold, because every penny we saved on the site was then poured back into the concrete frame. And then the roof. The house is one room. You see here the steel frame held back by cables. This was an early project where we expressed the structure. We moved away from that philosophy, but we were extremely interested in this 2x6, 2x12 construction to bang together in the US. It's a very cheap way of holding the whole house together. And this is how it looks, and you see how steep it is. The roof is tilted up, so the roof cannot act as a diaphragm to hold the house together. It's lifted up and brings the last west sun into the building. It's extremely bright into this thing. As you see, the light is coming up there, and here we are expressing the structure. See the light then Julius Schulman, for some kind of reason, got a phone call from Pierre Koenig, who was a steel case study architect. They said, there is a new house in LA, you should come and photograph it. He didn't like that this piece of land didn't have planting. We couldn't afford the landscape design. So he sent us to his house, and we took these plants from his garden. I think he had too many of them, and we had to plant them to stage this image that became for him an important image. So the landscape was done through negotiating with Julius Schulman what kind of plants he didn't want to have in his his garden. It had nothing to do with design. This is what happened for this photograph, and the plants are still there and growing happily. So we encountered these things. A few years later, we discovered termites into the house. Now, termites, something that we don't know in Europe, eat the wood. And so the house was being eaten away by little creatures. And since we knew that the house was being held together by the wood frame, we needed to do something about it. So we quickly grabbed the whole thing out and fumigated the hell out. At the same time, we received a commission in Switzerland from a client who wanted to have an American architect because he was convinced that Americans would do it quick, fast, and cheap. It's very important. And we arrived on the site and realized that half the site was missing. The park garage on which this store, it's a community store, had to sit, construction had halted because the community ran out of money. So suddenly we encountered some economic parameters. And so we couldn't put any loads coming down because the community thought that maybe one day they would continue to build on their park garage. So park and ride park garage. So it became clear that somehow the property lines is here in the air. It became clear that we had to cantilever the structure, but we were not allowed to anchor this private building on a public building. So no anchors allowed. The way we did it is we had a steel frame, and on the other side we used prefabricated concrete panels that were brought in prefab on site, placed onto the steel frame, and acting as a counterweight to the entire structure. And this happened within 2 days. So no big time for analysis and research. They arrived there is no site, half the site, be inventive about solving the issues before the engineers solve them for you. If not, you will get a mess. I guarantee you. I work a lot with engineers. You have to have the lead, 300%. Inside, cheap construction, American cheap construction, that you know very well. And on the outside, this became the facade, illuminated at night from below. So we knew the building had to hover, and we used that gap to illuminate this thing from below. So third project. This house became very important to us because it was an opening into computer-aided manufacturing in timber technology. We didn't know that the contractor used that technology. This is important to know because of the little detail. He was using it and we were totally naive about it. We didn't know this was happening. The house for a client, the most important room is for the husband who needs to escape from the family on the weekends and build his boats. So this was the most important room of the house, was for his boats. On top, the kids, and then his master bedroom, and then the communal spaces. So what we did is we built a super large garage. It took us very long to build it because it needs foundations and excavation, etc. With prefab concrete beams, and on top of it, a very light wood structure that was done with people that had just discovered machinery to build quick prefab using computers as the base. Digital manufacturing was important. So you see the house here, sitting on this concrete slab with the lights for the garage below. And here, when these panels arrived on the site, we realized that something was happening in our discipline and we had no idea about it. So we became very curious about that aspect, that the craftsmen, the manufacturers were ahead of the game of us. So we said, okay, let's learn from them. This is the final piece with facades made out of very simple sticks, wooden sticks that are operable. So you can close off the house with these sticks, but you don't need any sophisticated machinery, you just move the sliders by hand. this idea of moving facades as a sun shading device became important in this project here in Zurich. It's housing. There are 6 apartments, stacked houses. Each apartment is like a house, and they are stacked on a piece of property that was under historic preservation, was historically preserved, but the city was convinced to increase density. So you have these beautiful old turn of the century, turn of the 20th century old villas, and the city agreed that it might be wise to densify this neighborhood. We proposed 2 buildings, that you see here, with these stacked apartments. Very straightforward as a strategy. We had 4 weeks to develop this competition. The most important detail is this one here. So we spent probably 9 months in the collaborative teams with experts, facade experts, machine engineers, energy experts, structural engineers to develop this detail, while the rest was done in a very standard manner, straightforward as you can imagine. And this is the detail of this element, drawn at the scale of 1:1 in the office, with first with chalk on the wall. This is the outside, this is the inside. Here is the structure, holding standard concrete slabs. Then the facade enclosure, in front of the facade enclosure, panels that you can move, and in front of the column a little curtain track for private curtains that you could add. On the outside glazing, it's triple glazing. Generally triple glazing, there is one location where we have more than triple glazing. And on the outside, this mesh that acts as a visual protection to the houses because they are very near to each other, and as a sun protection device so that we don't overheat the building. No oil is used in this, or gas to heat or cool the building. So you're using geothermal energy. This was the second project where we used geothermal, and from now on, all our projects in Europe have no gas and no oil, and so CO2 free, at least in maintenance and operations, not CO2 free in production. We can't create concrete with CO2 free, not yet. So this is the detailed collaborative enterprise under the lead of the architect. You have to see this again. We work with experts interested in their discourse and transfer of knowledge, but everything has to come back to the design team and synthesize this knowledge. Good. Here we were doing an experiment. We filled the concrete slab with pipes, with too many pipes than even needed. The structural engineer thought that it might be interesting to reduce the weight of the structure, so it's like a bone thing. But then all the pipes, the air, the water, the electricity, and then reserve pipes in case something could happen in the future. We are still working with systems like that. It's less messy in the meantime. We have become a little bit more orderly in the way we organize the thing, and also think about how to dismantle concrete in the future as a strategy in our view. So this was the first experiment. It turned out into an extremely difficult mess. If you want to vibrate concrete in these locations, it's nearly impossible. This is so the detail that I showed you. The concrete slab is now here. The detail is in this location. You see the inner partitions that can be moved. You see the curtain track up there. This is the panel that can be moved. There are some also windows that can be moved to the side. And for the metal enclosure that you see here, we use fabric, metal stainless steel fabric that is normally deployed in industrial bakeries in Germany. So if you take the little breads, turn them around, and you see the pattern of this fabric. We use them here vertically to get the stainless steel fabric quite cheaply. And what you see here is the prototype. We tested the prototype for 4 weeks endlessly to see whether the mechanism is holding or not. In this spirit, there are new projects in the office trying to pursue this strategy of keeping the sun enclosure, the sun protection area on the outside. And here you see the building closing off and then entirely closed. This is done automatically. There are sensors. If there is too much sun, the building closes off, and you can override it as you use it. Bob mentioned this remodeling, so we became interested in larger urban projects, remodeling of an existing laundry factory on the lake of Zurich. First time we had to deal with historic preservation. This portion was protected, the tower was protected, this element was protected, the concrete frame was protected, so fragments were protected. And what we did is we continued the game, because the whole thing was already a bizarre assemblage of very different periods, and we continued to play this game, not being always respectful of the historic substance that we found. In some cases, we gave homage to the structure. In other cases, we put things on top, on the side, in front of it, underneath it, etc. The basic strategy is this kind of bricolage of different components for housing and commercial. There is a restaurant there, a store, office buildings. In order to tie everything together, we used the industrially prefabricated curtain wall facade developed for office buildings and applied it to the housing component as a continuous band that runs through the entire building, inside and outside. And at the end, in the restaurant, we got involved with an artist, a woman artist, Blanca Blara, who developed a very special piece in the restaurant. So what I would like to show you in this project is this element. You see this prefab facade, this band that runs through the building. Sometimes when it's interrupted, it moves in, but here it moves in and out. It's an aluminium balustrade that shows also that in this case here we were working with split the balustrade is taking deep into the building, creating double-story spaces, the loft, and this is the piece by the artist, where they say, okay, we are going to, it's like in a necklace, we're trying to hold that together. It's done in one specific location that is then mirrored into the glass. It creates an endless stripe of light at night. So, technical thing, then turned into spatial quality. In this case here with decorative, nearly decorative. At the same time, we had the opportunity to win another urban design project for Siemens. Siemens was involved in deindustrializing the factories that they had in Europe, turning this into a laboratory and turning their factory into housing. They're currently building those buildings here. This is coming maybe in the future. But one of the first buildings was the laboratory, and the laboratory had 3 courtyards. And in this courtyard, in all 3 courtyards, Siemens wanted to have plants. But there was no earth. We have a gigantic park garage below it. So we convinced them to develop, since they are technologists and love toys and gadgets, we convinced them to develop a hydraulic elevator on which, you see here, on which the pots can be attached, moving up and down for the plant. So you see, this is the device that they created. They're very proud of this thing. Attached to the wall. Here's the pot. Developed by the artist, and it moves very slowly. This is accelerated speed, so that I don't have to spend hours. So you see the flowers are appearing, and at night it stops. It's being fed with water. Another gadget that they developed. Our biggest project is the airport of Zurich. By chance, we were the underdogs. We won the competition. We had never done an airport before. So the question was, how we can create this super efficient machinery that processes 4,000 people per hour. That's quite a lot of people. We went on a world tour to see all the airports that were being built in Asia, and came back and said, no, we can't do that. No more formal exuberance with flying structure everywhere. We did exactly the opposite. We did a box with 4 corners, as straightforward as possible. It had to be the cheapest airport in Europe, and it had to be the most ecological airport in Europe. So 2 conflicting sustainability criteria. I believe that you need more money to be sustainable, but clients don't want to hear that. So important was the assemblage of a multidisciplinary team, different generations, different talents, different discipline, working for 5 years together under stress at the airport. So we created an office at the airport, and in order to survive, we hired a psychologist who trained us to talk to each other, to be prepared for client meetings, to resolve conflict between the architects and engineers, between the engineers and project managers, the age groups in the team. So she saved us meetings probably. We worked with images with the client in order to promote our ideas. Sarah in Los Angeles found this house not far away from San Francisco, and she said, this is your project. The most important thing in your project are these piles, because most airports are built on bad ground, where the city couldn't grow. We're in a swamp. And we will need long and fat piles. The 2 yards in diameters are the biggest one. We have 250 of those. So we took the image, we shrank it, multiplied it, and we told the client, this is your project. This is your building. It's a millipede. This is where most of the money is going to go. And what you see is only the tip of the iceberg. The most important thing is below ground, it's hidden. And what you see here is a diagram showing how important these red tiles became for the structure engineer, for the architect, because it gives you the rhythm of the entire structure, and for the mechanical engineer and energy expert. It's the first time we use geothermal energy with very deep piles, with plastic tubes that are going in the concrete. We put too many tubes in because we didn't know how many would be destroyed through the vibration process. And we can cool the building in the summer using the constant ground temperature and heat the building in the winter. Partially. Then we have additional devices. We have a quadruple facade creating a buffer zone here and photovoltaic to get the additional energy that we need to heat the last few degrees. So we're working on, you see the structure, the blocks get thinner and thinner in the higher they go. Then we use standard park garage construction applied into airports. So no big structure, just the standard spans that you can have. And this is the spaces that you get at the end. Every material is exposed. There are no hidden materials, so no fire can emerge within the layers of the construction. You knock on it, and it's what you get. Then we added terrazzo floor, some acoustic panels because we're terrified that it would be too loud in there. It's not a problem. And then you see these details. Those are the parking signs for the airplane pilots. So they know where to park their airplane. And we put clocks on the other side. So we have too many clocks. It's a kind of thing of Switzerland. You don't see everywhere here. This is planting in a restricted area so that they can't come and just cover the building with the stupid plants. So it's done by a landscape design implementation. And all the signage in the information system is just paint on concrete. Very direct. Those are the buffer zones where we put the ramps in. They're very important for temperature balance within the building. The lamps are painted blue and illuminated with neon, with blue neon on it. So you get a very bizarre, surreal atmosphere when you go down into the airplane. You're flying over blue and then you're trapped in this box flying to another continent. On the top we did a power plant with photovoltaic cells done in such a way to also shade the building in the summer. We get enough electricity to feed about 50 to 100 to one family homes in Panama. This is the view from. To make things a little bit more difficult, airplanes can't go over steps. The distance between the tarmac level and the departure floor had to be maintained. So everything is built by 0.6%. So that makes you a difference of 500 meters or 3 meters difference, 3 yards difference on one side. But you can hardly notice all the horizontals are built in slope and all the verticals are vertical. And here's the client who's been trying to explain this to the press. The press thought the building was sinking. So I spent 3 days on Swiss TV convincing that the millions they were spending were not leading to any damage. These are the circumstances. Okay, I mentioned computer integrated manufacturing. I would like to take you spend a little more time on this project. We had no work in the office at one point. This happens, economic crisis. So we said, let's do something fun. We had been in LA for a while and we were interested in standard construction. But at the same time, so you see here standard construction, and we were fascinated by this measuring stick. We thought maybe there is potential in it if you do a 2x12 pin connection. If you tighten it strongly enough, it turns into a moment connection. Maybe we could do a building out of it. In Japan. So we started with the first sketches. We had learned that Switzerland had a technology for computer integrated manufacturing, so we were dreaming of the technology. This is the LA office, dreaming of a technology that we didn't have. This is a stage photograph. So we pretend that somehow, miraculously, with lasers, we could take the dimensions, turn it into this, and then send it to the manufacturers and have it cut. So this is also stage. We're dreaming, imagining the impossible. And so by hand, because we didn't have computers at that time, imagine how long ago this was, we drew a tomography to the site. We got Arab involved to make their lives miserable. We put a fault line into the scheme. We didn't have the money to go to the site in Japan, so we invented the site. Oops, yeah. So here, first drawings on a computer, we found a supercomputer at the University of Southern California. And we said, okay, let's try. And we put these objects that we had developed in there. We realized there are two options. Either we would have doubly curved surfaces, or we would work with parallel structure. We decided not to go for the doubly curved surface. We were terrified about the idea of waterproofing on doubly curved. And we built this model with housing units, working spaces down here, and room spaces in between. And developed a similar strategy for the enclosure using plywood and piano hinges to connect. So this is one option. Put the enclosure on it. Enclosure is very important because it acts as a stiffening membrane, structurally stiffening membrane onto the surface of the structure, and then an additional structure, an additional enclosure with photovoltaic on it, grass, shading devices. So we were playing with this, trying to survive the crisis. Meantime, my students at UIC decided that it might be interesting to start building it. So we created these drawings, very straightforward, one-to-one, built. This is the measuring stick, full scale. And then we ran out of money. about 10 years later, we found this technology at another level in Switzerland, in the Swiss Alps, in a region of Switzerland where women received their rights of vote in 1996. So imagine how conservative that region is. And then, top down, they were forced to allow women to vote. So we said, okay, let's make a political statement out of it. And we organized the office, group of women, killer sharp women, to go there and get that baby built. With general contractor from the office, the apprentice, and the project architect. And they had a crew of men that they had to direct to this. The first drawing they did is a time schedule plan. We had only 6 weeks to build the project. It's a restaurant addition to a sanatorium in the Swiss Alps. And it became clear that everything had to be done. We needed a year preparation to build the 6 weeks. So the design of the process became extremely important, was rehearsed, tested with every trade beforehand in order to get the building done. Obviously, we had to use computer integrated manufacturing, and we decided to do the pieces as big as they could be, maximum size that could fit on a truck. And the information went from the office to the structural engineer, digitally back to the office for a check, then directly to the mill where the pieces were cut. But they were assembled by hand. So kind of an interesting combination between analog and digital work. The workers begged us to have more repetition and less difference. It's interesting. I told this to Greg Lynn. Don't believe it. They begged us on their knees. They said, we can't do it, it's getting too complex. So, straight pieces, repetitive pieces, or a few that vary at the end. We rented a shop and rehearsed the entire process, assembly of the building, with the crew that would do it later. We added the electrical powering, the panel, the water membrane, everything was ready on the pieces. And you see the truck in the back. This truck was redesigned by us to have an even bigger piece on the truck. The transportation route was carefully chosen. The height of this overpass became important and determined the height of the building. There's a circumstance, you say, okay, yes, 40 centimeters by law, this is what you get. Here's the truck, we designed to make this space fit on it. The daily schedule starts at 5:30 in the morning, and you need 2.25 hours. 2.25 hours is 2 hours and 15 minutes to build, to assemble one unit on site. It arrives on site on the truck, it's lifted into place with a mobile crane. They need to be ordered. And here is the addition being built in front of the sanatorium. When you see yellow, means it rains. So cover to be ready for the catastrophe case of rain and no protection device. So make sure that this is happening. And here you see a movie of the 6 weeks summarized in situ, the construction put in place, concrete, the first water membrane being applied to it, then the first templates arrive, also cut by computer. Those are the locations where the piece will be put. The ventilation system, because it's a restaurant, you have to ventilate it. Drains, cover everything. The first piece arrives, explodes here, and then moved back by the train, so it's a kind of clear it, always in this station, and then moving back. Then the last water membrane is a sink applied. This is the view when you arrive from the parking lot. You don't see people eating, and on the inside you have the view of building. Somebody had the idea that maybe it might be interesting to do a hairy building. One day, Sarah tried this in LA, the fire marshal said no, don't do it. Then we got at least snow and some girls. The most recent project where we realized that we needed to take computer integrated now to the construction site. So digital fabrication on the construction site for a school. So it's the American school in Zurich. We won the competition and found somebody who has a robot that can put the window units in place and then the glass into the window units. This is interesting. So we turned the entire school. The concept of the school became, it's like a factory. It's a workshop space. It's directly built. It had to be half the price of any public school. The American school had to be cheaper than the Swiss school. So we said, let's be direct. Again, another park garage, standard construction with concrete, and then these CAD frames placed in with the robots. You see the school has, there's nothing fancy about it. There's only repetition. So now difference is nearly out of the equation. Here's the school. The reason we want the competition is that we have a minimum footprint. We put all the functions in one building. The gym is this space here. The theater is here. The library is there. There's a greenhouse. And the rest is filled with classrooms and public circulation zones. And it's done in a very standard way. The repetition is broken by the long spans of the gym, the theater, and the library. By some components of the circulation system. So the circulation machinery, all the outdoor spaces are indoors because weather in Switzerland is miserable, so the kids have to be able to play within the building. Then the classrooms, and then the special public spaces thrown in within the entire machine. And the client liked this idea of having the school as a factory workshop for education. You see here the larger spans for the theater. So we break the in situ construction with prefab beams, concrete beams, to create the beams. This is the straightforwardness that I'm talking about. Dealing with circumstances of an economy of means that needed to be deployed, and here the large beams spanning across with puncture skylights, American construction that we know quite well, but it's also coming into the European market here. And this is the school with the gym, all the fire escape routes on the outside, liberating the inside, the theater and the library. This is the translucent street from the inside you can see out. This is the fire escape from the corridors. And this is the facade that shows you how the different elements and parameters that we need to address, such as skylights or ventilation elements, are brought in. And then the public transportation zone with the stair that takes you deep up or down into the building. This is where the kids live. Then again, we didn't have work, so second economic crisis. By chance, we got a call from Zahadid who said, would you like to participate in this exhibition? We had just won a competition for Adidas in Germany, where we decided to do a 1-to-50 model. And my partner Reto had the idea, so those are the Adidas buildings that I'm showing here quickly, each one had a different shape because the client was constantly changing his opinion about the size of the buildings. So we create groups of these buildings. And my partner Reto had the idea that maybe we should do a flying model. He said, how do you do a flying model? So you have talent in the office that has nothing to do, so you have a group of 10 people thinking about flying models. It'd be impossible. So we discovered helium, rediscovered helium. The second smallest atom goes through every possible surface you can imagine. It sneaks through everything. So we bought a lot of helium. We nearly ruined the office with helium. We had to find the super plastic membrane. We found a condom manufacturer who gave us the super condom. We realized that no helium atom would go through it. But then the problem became the seams. So the welding of the seams, we brought in a tailor who knows how to put fabrics together very carefully. We then found some very important equipment used in surgery, with medical equipment that takes some liquids and brings it into the body. So we said this is the way for us to get to the helium, to these balloons. And this is then the exhibition piece with the feeding of the helium. There were still some leaks, okay? So the whole thing collapsed at the end of the day, and it needed to be pumped up with more dollars of helium for the next day. Then after the exhibition, we sent them off, attached postcards, and one came back from us. These exercises from which we can learn, and we learned from this experiment. For this house here, this is a ranch in California, in a magnificent landscape, and we were intrigued by the possibility of taking now 3 of these balloons and then merging them. So the spatial bifurcations that emerged from this constellation is what intrigued us. This is a house built on the site of an existing house that burned down. Here is the caretaker house, here is the horse palace. So, the site plan again, let's get this studies, spatial studies of how to bring these different units to one another, in relationship to one another, creating a kind of trinocular with specific views through each of the tubes. Structurally, they are tubes. The client had a lot of storage requirements because they collect thousands of unnecessary things, and we use the structure as a space-containing wall full of storage that you see here. So the yellow is on the storage units, and here the addition of the 3 tubes. This is the tube for eating, dining on kitchen, your family room, living room, master suites with gigantic closets. So everything was done very smoothly, but then we got reminded of the fact that American construction looks like this. Bands together somehow, anyhow, and so we had to live with this as a circumstance. So this is the house cantilevering over the retaining wall with the garage in it. Then, because we're in a fire zone, with a super fire protecting layer, and then a water membrane made out of rubber on the outside. So we use the rubber now to wrap these tubes on both sides. Those are the 3 views of this unit. So to show you sophisticated construction and hit and miss construction in the same spirit. Deal with it. Those are the views from inside. This is not a Photoshop montage. This is from the kitchen, going simultaneously through 2 tubes at the same time. From wherever you are in the house, you have always the view of 2 tubes, and there's one location where you can see through the 3 at the same. And this is what interests us. If you're dealing with spatial applications, this is the other side, the negative of it. Then trying to find out how to build more like this on site is a nightmare. You have to be very thin to operate this. We took this idea of bifurcating spaces to the Children's Museum, Scheme 1. We won the competition with the idea that it would be integrated into the landscape. It would be the most sustainable building in California. This was the dream. And that the roof, the kids could walk on the roof, climb up on the system of ramps and reach this point and we will view the park. The entry here and another system of ramps inside it. So let's keep this in mind. This is the site. In the 40s, LA built 5 gigantic dams. We had the Hansen Dam site, infrastructure to protect the city from floods. So we built, we work with aerial photographs. This is the dam, and the side, our site is this little triangle here. And we built the model of it to understand the structure of the site, and realized that it's built out of a series of plateaus. There is hardly any water. It never rains in California, but when it rains, it fills it. The 100-year flood comes to our site. So we have to keep this in mind. So we did a series of models very quickly and ended up with this one where you see that here you can identify the individual elements. And here everything begins to merge, create this flow of the circulation going through. So this was the development, the evolution of the scheme. And in parallel, we developed very quickly, this was done in 3 days, with trying to identify which function would be where in the series. Now, talking to the Children's Museum, because of people dealing with children, they wanted to organize every workshop like a children's game. So this is the partner that we have at the table. So for the circulation, we used string. We said this is the system of ramps, this is the system of going in, on the ramp, moving into the building, etc. So playful devices designed in such a way to communicate your ideas with the client. You have a participatory process, but you have to take them somewhere in this participation. Translation of the building will be in a drawing, administration, bookstore, restaurant with English ramp, theater located in this location, etc., and the gallery spaces. The client then called us, board of director meeting, and said, architects, we would like to have a Spanish colonial house with red tiles. Let's pretend. So we said, give us a chance, and we went there, and since we always talk with our hands, we tried to explain the scheme with them using our hands. So he said, this is the administration part. This is the first plateau with the first galleries, temporary galleries. Then the second plateau on top is a reference to the site with more galleries. Then we will have a series of trainers with special functions such as the bookstore and the theater reaching into the park. The park has trees. The trainers will embrace the trees. And ultimately, this is the building that we would like to give you. From then on, no more discussions about red tiles. They said you understood the spirit of treatment, blah, blah, blah. They said, great, let's build it. So we did models, architectural models, and since it had to be the most ecological building in LA, we worked with the predominant wind direction, put photovoltaic on the roof, the drainage system became important because the water had to go to the dam. We created some kind of an air cooling system where the wind would be cooled before it goes into the building. Remember, we're in a climate desert. Geothermal that we had experienced this in Switzerland now for the first time applied in California. More geothermal in this corner. Sun protection devices, a lot of earth in it as an insulation layer, and a wood deck for the final moment to reach the top. And then we tested this air conditioning system in the office. So this is the LA office, where we use very thick pipes, sprinkled with super nozzles that create water particles and open the garage door, and we are still using it to cool the building in the office. Then we did rendering and got an award from the AIA. Everybody was happy. We did 70% of the working drawings, and then 9/11 hit. The total collapse of the building industry before the housing boom, total collapse. No more money from the donors. Deindustrialization with increased steel prices in China. No more steel being manufactured in the US, so every steel had to come from China. The Chinese needed their own steel. The building got more expensive week by week. The client said, stop. can't, although you're 70% into working drawings, stop. We give you 3 days to redesign your building for half the price, same square footage. And then they said also, why don't you do a Walmart big box? Okay, the new Walmart big boxes from our research. We at the university, we were very critical of all this. Said, okay, let's try to do something with big box. So tilt-up construction, we became fascinated with tilt-up construction, where you pour the slab in place and then you move it up for the wall. It's part of the structure. Colleague of mine who was here last week, Jesse Le Cavalier, did a wood box with sand, and we smashed the box that had to have, thank God, the triangular shape because the side was triangular, and we pushed the building as far as we could in the earth so that it can be cooled from ground temperature, and did the theater, the store, and all these other things that are required, this very simple wood frame construction in front of it. It's a one-story building. Quick hand drawings, because the hand is still faster than the computer drawing. The section to it, this is the slope, this is the building cutting to it. We did a very large roof with photovoltaic glued onto it. The tilt-up slab panels here. And the first model, the tilt-up slab, very standard construction now. No more heavy concrete folded plates, creating ramps that takes you to the roof, and this very simple process in front of it. Dealing with economic constraints and negotiating them. And then a very simple roof as a double roof membrane to protect the building from the sun, saving a lot of energy. Then puncturing the roof with standard skylights, the cheapest skylight you can find on the market. And then we discovered that the guys that had done the rubber house had developed super rubber with photovoltaic cells glued onto them. So this is great, you can just try it. It's less long than a good photovoltaic panel. So what? And then we got the second award for the same project, with the same rendering, we just changed it. And did up on site. Time-wise? So did up 5 more minutes. Then the steel beams here tilted so we get some sunlight. And this is the view of the dam with the triangle building. This super roof that we call the rabbit ears hanging on each side using the same rubber. The first finger sticking out, the conference room here. The standard, how cheap this is, how short this was the fingers reaching towards the park. This is the bookstore. The bookstore reaching into the building, penetrating the enclosure. And culminating into a gigantic ramp. Now the building, we finished the building about 6 months ago. It's empty. They don't have the money. After the housing boom, another crisis, the current one, no more money for the exhibition. So it's empty. Welcome to architecture. Good. The last project is the aerial tram in Portland, Oregon. Recently, I stumbled on this fashion magazine, and what was in the background was our building, without credit. Some popular press picked it up, emphasis on the beautiful bodies, and we never had an 18-page spread in any magazine in our life. But always in the background. So that's also life. So nobody's mentioning your name. Disappear, the team disappears, everybody disappears, engineers, everyone. But the interesting thing about this project is Portland has an interesting tactic to make the city sustainable, and they introduce public transportation very early on in the game, ahead of many other cities, and a lot of European cities are coming to Portland to study. What you see here is a tram that they recently built with streetcars that you know from many American cities. And then one special one, and that's the aerial connection, and it's this one here, that's called mine. The assignment was to connect the campus, the hospital campus, with the new campus on the river, and to bring in the doctors within 3 minutes from one campus to the other. That's the brief. The only way is you fly. And so this is the whole campus. We had to fly over a freeway, historically protected neighborhoods that caused us a lot of trouble, political trouble, park, then the upper campus. You see here the section, the lowest station, the central mast, the upper station. Those are the key. So we built a model with 3 proposals for connections. The aerial connection, that's the fast one. Then a path that takes you through the city, up the hill to the park, and a very large park. Obviously, they built only the tram, the rest nobody. So those are the key components that were developed with the upper station, the bubbles, the central mast, so there's only one, and the lower station. So I want to show you these components rather quickly. This is quite a challenge for the engineers because we didn't get any ground to put the structure on. There was an existing park garage underneath the street, and we were not allowed to touch the hospital building because they were doing heart surgery in there, so no vibration transfer. And this is a cantilever from the ground, 0 tolerance on top, so it can't move. It's the cables could jump from the tracks. Okay, so super stable. This is the upper station, so just barely like a ballerina touching the ground. We created 2 V's that intersect plus 1 corner which is in this place. This is steel, super steel construction, solid, done in a shipyard. Down the river and then brought to the sea. I want to show you this detail. This is the other view of the enclosure. Very light. The bridge connect. By the way, when they built, this is a cantilever, this is a cantilever from the cantilever. They had made a little mistake of a few millimeters here. They missed the opening by 40 centimeters. That's not so much. So we had to rebuild the facade of the building around that opening that missed it. Okay, so this detail, the next shot. Here is a kind of prototype built by the kids in the office. Quick model. You can stand in this thing. Stay here. This is the shipyard where this was manufactured. Promoting American steel in the US. Then the enclosure that the politicians wanted to get rid of for cost savings. Sarah took the politician to a nice building to the edge and said, "This is without enclosure. This is the feeling you get." He said, "Okay, let's do it." So you have to be very creative and bloodily aggressive. She screamed at him. This is the idea of the fabric is that you get a moire effect and day-night change while you move on the gondola. Sometimes you see through and sometimes not. By the way, this prototype was done in the yard of the office. Here the assembly of the skin. The skywalkers, basically. Central mast. The tomography to the mast. Derived basically in collaboration with the engineer for the loads. And then the mast arriving by boat, by barge. Then put onto a gigantic truck. Moved very slowly to the sides. Then we closed the freeway for 5 hours. Imagine closing the freeway, how logistically complicated it becomes to shut down the freeway for 5 hours, and then we build this thing overnight. This is the next morning. And then we added this contraption piece by piece with the little crane. crane moving them. So this is the final thing. This has become one of the key elements in the city. The lower station come with the standard construction, straightforward. This is the lower station in its current state, seen from one side. It's still a shipyard. You see that the campus is being gradually built around it. And this is the view from the other side where you land on the square. You create the square. So the gondola arrives on this level and you go straight into the public space. So it becomes part of the continuity of the public space. Then the bubbles were manufactured in Switzerland. There are two of them in jig-jag counterweight system. One rules the other. And the challenge became a doubly curved surface because we wanted to have smooth surfaces for this thing to disappear so that the historic preservation neighborhood would be too critical of what they would see. They didn't want to have an aggressive object up there. So we said, let's do it smooth. But then to get the smoothness, it became extremely difficult. We were dreaming of CAD-CAM at that time for this. They said, no, we have two old guys, retired specialists in Maseratis. Because Maserati is built in Switzerland, was built in Switzerland. They came back from retirement and did the bubbles for us. We were very proud of the job. Then very simply assembled. And here's the bubble in operation, and it's truly functioning. Within 3 minutes, you are from one campus to the other. We were lucky that as soon as it opened, there was a snowstorm, and a kid was brought by ambulance in the lower station. The ambulance couldn't go to the upper station, and that gave us, we saved the kids, and with this we got positive public reactions, which become in these political difficult negotiation processes that you encounter, those little events. You see a reflection of the upper station in doubly curved glass and approaching But then the question was, how should it appear at night? So we decided that it should not be screaming, that very little light should be used on top of the skins of all three pieces. And we worked with experts on it, so here you see the light coming from below. Here we use mostly some lights here, and then we use the orange of the freeway. The whole freeways look orange at night. And then the lower station with lights. And this is the calendar shot. I found a calendar where showing the tram with Mount Hood and the sort of icon. Good, so this was cut through the work. And I would like to end with these cadaver ski sketches by a group of surrealists with André Breton, Tristan Tzara, Hans Marc. I think we have, as architects, become quite interesting creatures. We have to be able, while encountering the most bizarre circumstances, to react to them, to be fast and charming, and be able to talk about costs, and be able to tell to a guy on site to rebuild the wall, a guy who is twice your size and his hands, and could kill you tomorrow. With your hand, so you have to rebuild this wall. You have to be extremely intelligent about cost. You have to constantly maneuver around these obstacles that are placed in front of you, while still imagining six impossible things for breakfast, and constantly pretending that you are an architect. Thank you very much. Questions? questions, critiques, suggestions? Yes. One. Yeah. Okay. Art. Art.
Inside of architecture, as opposed to outside.
No distinction. As a matter of fact, we usually start from the picture and try to understand what parameters are. But the parameters can be site constraints, or it can be fire escape routes, or it can be cost. And somehow when these pieces come together, you might address the inside, you might address the outside, you might oscillate between the two aspects. So in contrast to Herzog de Meuron's school, which are colleagues of mine that I dearly admire, they started their career from the outside. It's all surface appearance. And then to justify it, reference to contemporary art of floors, Wagner, blah, blah. You say, yes, sure, enclosure is important, but it cannot become the exclusive brand of architecture. We are also space makers. But that's our trade, that's what we do. Did I answer your question? Yeah. Surprising question. Yeah. Yes. That's an interesting question. We too.
Yeah.
Yes. You encounter a circumstance, you redesign it. You find something and you reframe it. And you declare it as this new circumstance that you have created in the design process. I think this is the trick. You don't sort of say, oh, I'm a victim of a circumstance. You have to reframe it. You get a competition brief, you realize, well, you want so many square feet of everything. You might realize that something is missing. So you say, circumstance is missing public space. So we are bringing in public space into competition. So you have to be in control of it, or pretend to be in control of it, and constantly redirect the parameters. And never become a victim of them. Sometimes you encounter engineering and tells you this is not possible, and those are the circumstances, and you say no. You say, we can do it, and we have new circumstances. And then use it tactically in the negotiations with the clients to convince them that this is the correct solution. With charm and sometimes doubt and laughter. No. No, it not always works. This is when we fire the client. Yes. 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 It is a tradition. In the tradition in Switzerland, you're also general contractor. So the architecture fee by the Swiss AIA is structured in such a way that still you finish the building and you give the key to the client. And then sometime afterwards for warranties. This is all covered by the architecture. Unfortunately, the Swiss have discovered the American system. Okay, so they say, we can cut the honorarium and let's give some to the general contractor. Okay, or let's have the general contractor faster than you and cheaper. And for example, for the airport, we convinced the clients that we would be cheaper than the general contractor. We had the super fee on top of everything. So we did the airport of the office. We got the quality. We started to apply this model for projects in LA. Not for the airline. In there. We got scared. We building castles in the air.
I was just wondering if you could talk a little bit about sustainability and sustainable construction and its relationship to architectural ideas. And it seems like a lot of the time people are addressing sustainability in terms of technology, and I was just wondering if there's more to it than that for you and architecture.
Well, let's say it's a given. Our buildings in the future have to be sustainable. That means less CO2, using alternative renewable energy sources, etc. But we don't make a big deal out of it. In the beginning, the first geothermal very excited about. It's just part of our trade. So not, I can't go to our building and say, you see sustainability. We have to make sure that as architects, we are in control of the debate. Because what has happened, other trades that we work with have discovered sustainability as a new justification for whatever they do. It has revived the field of engineering. Suddenly, the mechanical engineers are God. It's very interesting. So suddenly they were somewhere backstage and suddenly they are center stage. And so therefore, they come with new parameters that you need to negotiate as well. There are conflicts within sustainability, and those are the interesting ones. In the Children's Museum, everybody said it has to be environmentally sustainable, but when economy hit, everybody said it has to be economically sustainable. And nobody was willing to spend a cent on the environment because they needed to save every spend for the basic structure. So environmental sustainability was thrown out the window, and justifiably so you could say that economic sustainability had the lead. So those are the moments that interest me a lot. So how can you do sustainable building, because this is what we need to do, as cheaply as you can without faking it that it's sustainable. So at the end, with the Children's Museum, I showed you using air conditioning, using gas. We're far away from the dream that we have. But funny enough, Europe is not a problem for IUCN, we're just doing it. But then sometimes we're in conflict with the law. We are developing now a building without insulation in Switzerland, where we can use, we're going 300 meters down in the earth, covering the buildings with small pipes, and transferring just the heat from the earth onto the enclosure, and the coolness of the earth onto the enclosure in the summer. As the earth is being constantly heated up by the sun, fantastic, it's the cheapest energy you get. Petroleum companies don't like that so much, because it's a super competition to them. But the code in Switzerland requires that I do 35 to 40 centimeters to 50 centimeters of insulation. The energy code requires you to do insulation, but we want to avoid that. So I'm going back now to Switzerland to talk with the code guys, trying to convince them with some intelligence that our system might be good. Let's see. They have to adapt their code.
The presentation was fantastic. Exploring the greater invention through practice. You're the director of the School of Architecture. What is important for students to get in school? What's the most critical components of education?
From practice.
From practice.
Different, I mean, it's very difficult marriage. Academia and practice. I don't see academia in the service of practice. Of course, we have to train them to become professional people, but I don't see us in the service of practice. I see us as the guys in academia that will also inform practice. So this is a trajectory that practice goes. But practice usually doesn't want to hear that. Every possible barrier that you can imagine. Besides teaching, our responsibility is also research. It's important for design faculty at my school at least to be in practice, to research and to teach. Giving three-legged octopus. Promotes research on the front of the discipline. So push the envelope of the discipline. Try to find ways to translate this into practice, into teaching, because the students are often part of the research, and try to find transfer mechanisms of knowledge into practice. That means you have to invite practice. So when the accreditation board comes, because we have that too, they are coming from practice. What they want to see is practice. So we have to say, but also we have other responsibilities. This is where it gets difficult. It's not a complicated answer. It needs to be but I appalled the idea that we are in service. I learn from it. And in the hall, we go to the shops, we talk to craftsmen, we try to learn what they live. It was interesting to hear that they wanted more repetition and less difference. We thought with CAD/CAM we could do more difference, more difference. They said repetition. So that took us back to the 1920s when we were doing standard construction. Standard brickwork. Did I answer?
You answered for me more the relationship between the teacher and the school, in a way. But I would say that if I was to put myself in the position of the student, knowing you don't have access to
Let me try a second.
Yeah.
We have to teach them to become killer sharks,
Okay.
charming ones, and can maneuver through every potential problem that we will encounter in the future, and be creative about it and make propositions and be able to translate it into this. Unless you go into academic career, then you push research itself. So that becomes super tough.
There's a number of here at architecture school, and if there's a spectrum between broad-based education or a few things done well. Clarity of your analysis and simple what table. Which one is more important?